Alright, I would go ahead and start my recording. And I will say good afternoon, everybody. And I'm processing my 250 video in the background. Hopefully it doesn't totally lag my machine, but my fan kicks into overdrive when I do that, so it's definitely, it's cooking something. Got 411% of my CPU in use by a command called melt. Well, that's appropriate, isn't it? Cool. All right. So I got PA1 grades posted, and I posted feedback on those. And probably you knew what grade you were getting from the grading rubric, right, based on what ran or what didn't run. The only thing that might have caught some people by surprise was the 20 points for style and commenting and such. And by and large, the style on people's code was fantastic, right? People are indenting. Their indent level is based on how deeply they're nested, which is exactly what the purpose of indenting is. And so that was great. The place where I saw some room for improvement, though, was in commenting. Okay, and it's not necessarily the number of words you use in the comments, but you want to make sure, first of all, that your name is on your code. Okay, this is your code. Put your name in it. That goes in a comment block in the beginning, along with a description of whatever it is that you've written, in this case the even class, right? And you should describe the class in your own words, what it does, what it's for, what the basic construction is, and so on and so forth. Now, you're going to describe a lot of detail further on in the code where you actually write it. But you want a synopsis of the class itself, right? And if you look at the Java documentation, right, this is kind of a template for how you can document things, right? The name of the class and a description of it. The string class represents character strings. All string literals in Java programs are implemented as instances of this class, right? So the even class, represents even numbers. It works like an integer, but it can only assume, even values. Something like that, right? The class provides ways to manipulate evens that are guaranteed to return an even, okay? And then every method has to be described, preferably in a block of comments right before the method. So before you actually declare the method, right, and write the code for it, have at least, a one-line comment that says what the method does, okay? And be descriptive. Don't just say add method, right? This method takes an even argument, adds it to the object's value, and returns a new even, okay? Divide, what do you divide? You divide the argument by the value or the value by the argument. Same with subtract. What happens when you divide if you get an odd number, right? What happens when you add and you get an odd number? Well, you can't if you're adding two evens. Mention that, okay? So spell it out and then go ahead and put comments on the lines of code, and that looked pretty complete, commenting the code itself. But the toString method is fairly complex, right? It's got a lot of steps to do in there. If you have one comment in the beginning which says, convert even to string, that's really not what I would call sufficient documentation, right? How do you convert it? What's the output? Well, it's something very unusual. It's a bunch of English words, one word per digit, right? It's not even a normal way to represent a word in written form. So it's something very peculiar. Persons looking at your code should be able to see the comments in front of the method and know what the method does, what the arguments are, what the return values are, what the side effects are, what the possible error conditions are. Okay, so if you lost points for that and you're not sure why, talk to me about it and I'll give you more specific suggestions. But I tried to give you specifics in the comments on Canvas, and we can elaborate on that further if you like. So PA1 looked good. Keep going with PA2. Tomorrow's class, I'm going to do Open Lab again, okay? A few people showed up last week. I'm hoping more people show up this week. This is, in addition to 8 office hours a week, time that you can show me code and you can screen share and we can work through problems. I can help you debug and so on and so forth, okay? office hours, lab hours. You're competing for my time with, you know, whoever else wants to talk to me for advising other classes and so on. Tomorrow, lab time during class is just for CSE 223. Okay, so you've got my undivided attention there. Take advantage of it if you have questions or issues. So I want to play with hash keys today. Okay, hash maps and linked lists, and I want to work up towards something that might help you with PA2. Okay, I did this in the morning section, but I was kind of figuring it out while I did it because I was changing my idea of what to present. So I'm going to do this again in here from start to finish. And the useful takeaway from this is probably the process, not the code. Okay, the code from the morning is already posted in the shared area. But it's the process, the way of getting to this and sort of working towards it, or creeping towards it, as one of my professors used to say, creeping towards the answer. That I think is the better takeaway from all of this, as opposed to, you know, just a set of code or something. So so let's write some code. And the first thing I want to do is write a program that interacts with the user and lets me get and put stuff. Okay. So I'm going to say get. I'm going to say put. And then I'm going to say what I want to put. I want to put some, I'm going to have words and things associated with words. Okay, so I can say put, and I'm going to put the word cat, and then I'm going to associate with that the word furry. And then I'm going to say put, and I'm going to put the word dog, and I'm going to associate with that barks. And then I can say get cat, and it'll tell me furry. Or I could say get dog, and it'll tell me barks. Okay, so this is just going to be a way to play with some basic simple commands, right, that we're going to get using a scanner on system.in, but then building up a hash map that will store a key value pair. So there's a key and there's a value. And for example, if the key is cat, the value is furry. If the key is dog, the value is barks. And I'm going to write a simple front end that lets me load this stuff in while the program's running, and then say get to interrogate what's stored in the hash map. So this is what a teacher used to call junk code. Okay, it's not anything that you're going to turn in. It's not something that you're going to necessarily work from. It's just a way to explore different aspects of different pieces of these programming constructs. So so let's go ahead. I always forget to record, so I keep checking to make sure I'm recording. Let's go ahead and make a main program. So sample code, read and save info. And then retrieve it. All right, we're going to need to use a few things in here, so we're going to need a scanner, and we're going to need a hash map, because that's where we're going to store our information. All right, so what's our main loop look like? Ask the user for a command, which is going to be get or put. And we're going to process that command. We're just going to repeat this forever. Okay. First thing we're going to do, though, is we're going to make a hash map. So we're going to store key value pairs. right? Where key is the thing that you use to look up a value. Okay, so key is sort of the thing we're using to search for the values, right? PA2, key is the word that we found in our input, and value will be the linked list of locations. Okay, for us, we're just going to store words. Okay, so the key and the value will both be strings. So hash map, and what should we call our hash map today? I'm just going to call it info equals new hash map. And when you construct a hash map, you don't need any arguments, okay? You can specify arguments to modify its construction, but it's perfectly fine just to construct a hash map with just new hash map paren, okay? But we do need to specify what kind of objects the keys and the values are going to be. So we have to satisfy the fact that this is generic. So I'm going to say keys are strings and values are strings. And then over here at hash map, we're going to use a pair of strings. I'm going to make an alias, which I'm just going to call C to compile my main program. I'm going to make an alias R for run to run my main program. But it's got to be a lowercase j and an uppercase m. Alright, so when I want to compile, I'm just going to say C. When I want to run, I'm just going to say R. Okay, that's one of those things that's going to save me, you know, a second here, 2 seconds there. But over my lifetime, it's going to be like living to be 300 years old. It's going to save me so much time. It's fantastic. All right, so let's write our main loop. Let's get input from the user and process it. Okay, so we'll start off by prompting the user. And we'll say enter a command. And I'm printing it with system.out.print instead of print line because I don't want a new line at the end. I'm going to say enter a command, and it's going to sit there right after the colon and wait for me to type something in. Okay, how do I read input? Well, I'm going to need a scanner. Okay, so let's make a scanner. So I'll construct a new scanner from system.in, and I'll call it SC. Okay, and that should still compile fine. All right. So we're going to read a line from the user. So we're going to do this in a loop. We're going to read as long as there's another line of input available. Which means when the user hits Control D, we'll exit this loop. So as long as there's more stuff available, so let's say command equals sc.next line. And this should be either a put or a get. Okay, those are the only 2 commands we're allowing. Okay, this is not going to work. We can't use equal equal to compare strings for the same reason that we can't use equal equal in C to compare strings. Okay, equal equal compares 2 numeric values. In this case, it compares 2 objects and it says, are these the same object? Command is a string, put is a string. They're not necessarily the same object. In fact, they're almost certainly not, because put is a string that's defined in double quotes, and command is a string that I defined right here. They're different objects. They might both have the same characters in them, but equal equal will come back and say false. So we want to know, is the contents of the string inside command the same character by character as the letters in quote put? Okay, so we use a method. In C, we use string compare. In Java, we use the equals method. Okay, so if command dot equals quote put. So this says take this string, compare it to that string. And the result of this method call will be a Boolean. It'll be either true or false. So I could do this, but that's kind of redundant, right? The left-hand side of this is a Boolean, and if it is true, then this if statement will fire just with that. And this kind of reads, you know, logically, if command equals put, then let's do something. Well, I'm just going to print a message for now that says in the put section. Else, if the command equals get, then I'm going to say in the get section. Else, I'm going to say error. Please use get or put. And, you know, if I want those to be in quotation marks, I can do a backslash quote. If I just say, you know, a quote, it's going to end my string. But I'm going to say, please use quote get or quote put. And that's the end of my while loop. So I've got a template for my program, but I'm not doing anything with a hash map yet. Okay, which is fine. We're building this up. So let's go ahead and compile this, and let's go ahead and run it. So enter a command. If I say get, it says I'm in the get section. Oh, I forgot to do something else though. So what did I forget to do? The thing that I always forget to do. So let's print a prompt again at the bottom before we go back up to get more input from the user. Right, let's print another prompt which says enter a command. So let's compile that and run it. Enter a command, and I can say put, and it's in the put section. Enter a command get, it's in the get section. Enter a command ha ha ha, and that's an error. Please use get or put. And when I hit Control D, it takes me out of my program. All right, so building up functionality. Any questions up to there? Okay, cool. I'm looking at Zoom on my phone. Okay, cool. So let's do something in the put section. Let's actually save some information. So So let's ask the user to tell me what it is that they are going to save information about. And let's say string item equals sc.nextLine. And then let's say tell me something about item. And let's get another line of information, and we'll call that data. And then let's store that in our hash map. Okay, let me call my hash map something different. Let me call it database, because that sounds fancier than info. Okay, so store this in the database. Well, if you look at the documentation for Hashmap, there's a put method. And put takes two arguments. It takes a key and it takes a value. Okay, the key is the thing about which we are storing information. That's just item. And the value is the thing that we're storing about it, which in this case is data. And then we're pretty much done. So if we say put, it will ask us what we're describing. We'll type in the name of our item. It'll ask us to say something about the item. We'll type in a description of it, some data about it, and then it'll store that data in the database associated with that item. On the other hand, if the person says get, instead of saying in get section, we'll say tell me the item you want to know about, and we'll get an item, and then let's retrieve this. So let's say string data equals database.get item. All right, so I'm going to take the item that they want to know about. I'm going to use the get method on our database. That's our hash map. That should return an object of type string. That's the type of data. And I'll store that in a string called data. And notice I declared a string data here. I declared a string data here. Since I'm inside this if statement, right, this is local to this block, I believe. We'll find out if I'm wrong. Yeah, we're good. All right, so so these are tightly scoped variables, right? I could declare variables up here called you know, info and data, and I could use them here and here. I could even declare them as part of my main class and make them global everywhere, right? But I'm making them so they only exist within this section of code, right? Which is going to minimize the chance that I accidentally use them somewhere else that I didn't mean to. Okay, so I'm going to retrieve a piece of information from the database, and then let's print out a message. And I'll say, here's a fact about whatever the item is, and I'll print out the data. All right, so that's our basic setup. It's just a sort of simple pair of commands, but it gets us using our hash map. Okay, so let's see what this does. Let's compile it. Let's run it. So enter a command. Well, we can try to get stuff from the database, right? Like haha. Here's a fact about haha null. Okay, let's clean that up. String equals database.get item. So if item equals null, that means the item is not in our database. So there's no info available. So we'll say, I don't know anything about item. Otherwise, we'll print out whatever our fact is about the item. All right. So we're just building this up, right? Compile that, run that. Okay, so let's get information about haha. Oh, did I not compile it? I did not compile it. did compile it. Sorry. If data equals null, there's no information available on the thing that we retrieved from the database. So if data is equal to null, then no information is available. Alright, so let's get information on haha. It says, I don't know anything about haha. Okay, so let's put some information in about haha. Tell me something about haha. What people say when they laugh. Okay, now if I say get information about haha, here's a fact about haha, what people say when they laugh. Yeah, you can use makefiles with Java. Absolutely. When you compile a Java program, if it needs a class file that doesn't exist yet, and it finds a Java file in the same directory with that name, it'll go ahead and compile it for you. But if it finds a class file, it won't look at the dates and recompile something. So yeah, makefiles can be useful. Alright, so let's put some information about dog. Tell me something about dogs. They are fun to play ball with. Okay, let's put some information about cats. Tell me something about a cat. They don't play ball usually. Okay, and let's put some information, well, that's enough. So let's get some information about a dog. Dogs are fun to play ball with. Get some information about a cat. They don't play ball, and so on. Right? Get information about a parrot, and doesn't know anything about a parrot. Alright, so we're storing and retrieving information, right? And these are long strings, right? So I could put information about large dogs. Tell me something about large dogs. They are very large, right? So if I get information about a dog, it tells me that. If I say get information about large dogs, it gives me my information about large dogs, right? So these are strings, but they're being used to access information. Okay, it's an associative array, right? Associated with this object is that object, and so we can go in, with a string, which can be, multiple words, spaces, that kind of thing. We can pull out a value associated with it. Okay, and Control D ends my loop. I'm going to add an exit message here. Because when I end my program, my Unix prompt is coming out on the same line. I don't like that. So if I hit Control D, now it'll come down to a new line. Whoop. And I got to do a print line. Alright, so we get that kind of behavior. I'm compiling as I go for a few reasons. One, because it makes me feel like I'm making progress. Two, it stops the unpleasant experience of compiling for the first time and getting 572 errors. Three, it lets me know if I'm doing something systemically wrong, right? If I'm consistently doing something that doesn't make sense, I might do it 10 times, and then I'm going to get a whole bunch of errors when I compile. So if I make a mistake, right, then I'm going to catch that earlier, especially since I'm tending to copy and paste a lot of code. It's really easy to copy and paste the same syntax error, a half dozen times, and that's kind of a bummer. Alright, so I'll make a copy of this in main 0, and we'll keep modifying this program. So this is a hash map where our key is a string and our value is a string. So let's extend this. Let's change the value to be a linked list. Just randomly, right? Not like it has anything to do with any assignment you might be working on for the next few days. But we'll just have keys that are strings, and associated with each string will be a linked list. Okay? I'm not going to do a linked list of integers, because that's your PA2. but I will do a linked list of strings. And so what we're going to do is we're going to let you store multiple pieces of information about your key. Because if I run this right now and I say put, cat likes milk, and I get information about the cat likes milk, and then I put information about cat and say it's furry. Well, now if I get information about a cat, all it tells me is it's furry. It's forgotten that it likes milk, right? Because we were just storing a single string. So I want to store a collection of strings. And I could use an array, but I'd have to decide how big the array is. So I'm going to use a linked list instead. So this is going to be like our PA2 setup. We're going to have a hash map. The key is still going to be a string, but the data is going to be a linked list. And a linked list is also a generic. We have to specify a linked list of what kinds of things. So a linked list of strings. And we'll do the same thing over here. Alright, so what does this change? Tell me something about item such and such. Alright. We're going to do something different here. We're going to let the person type in multiple statements. Okay? And when they're done typing in statements, they're going to enter a line that just has a single period on it. So let's do this. Enter one fact per line. End with a line with just a period. Alright, so when it says specify the item you're saving information about, we'll get the line from the user, and then we'll say tell me some things about this item. Enter one fact per line, end with a line with just a period. Okay, so we're going to have an input loop here. Now, I could throw this all into a function, and that's what I did this morning. So if you want to see this broken off into a separate function, you can look at the code and the video from that. But here we're going to just put it all inside this one loop. So this is not a terribly modular design, but just giving you a different style of it from the morning class. So let's make a loop which lets the user specify input. So we will read a line from the user, and I will say while data dot equals a single line, a single period. I'm going to say while that's not the case. So while the user has input something to save, well, what do I want to do? I want to add that piece of data that the user just typed in to the linked list associated with our item. Well, we don't have a linked list yet, right? So before we do this, let's make a linked list. So specify an item you're saving information about, and the person typed in an item name. So make a linked list in which to store facts about this item. So construct a linked list of type string equals new. So linked list, what should we call it? Fact list equals new linked list of type string paren. So fact list is a linked list. Okay. And let's add some stuff to that. Actually, let's go ahead and do this. Let's add this to our hash map, okay, which is called database. So how do we do this? We say database.put. So associated with the key, which is an item, we're going to store this fact list. And I'm doing it in this order on purpose because it's kind of weird, right? Our fact list is an empty linked list, but it's an object. It's a linked list. If I come along later and I add some stuff to this linked list, right, that list which is inside my database is going to have that new stuff that I add to it. Okay? It's not like I'm copying this from one place to another. I'm actually placing this object, fact list, which I just constructed here, into my database, into my hash map associated with item. Even though it's already in the hash map, if I add something to this fact list, right, when I go into the hash map and I put in the same item, it will pull out this linked list that I just added something to. Okay? This is a little mind-boggling in some ways, right? It's pretty impressive that it works. So I'm putting this linked list, this object, think of it as a single particular linked list, into the hash map associated with whatever that item is. Okay, now I'm going to ask the user to enter some information. So they're going to type in something in response here, and while it's not a period, what am I going to do? So let's add this to the linked list. That's just factlist.addData. So we take the thing that they typed in, which is some sort of fact, and we add it to this linked list. And then we're going to get another line of input from the user. Read another fact, or an end of process command. And that's the end of our input loop. So all of this is the code that deals with a put. And it's mostly print lines and inputs, right? It's really create an empty linked list, put it into the database, and then every time we get a piece of data, add it to the linked list. And watch for typos. Alright, otherwise if they say get, specify the item you want to know about, we'll get an item from them, let's retrieve the info from the database. So say, and this time what we get from the database is going to be a linked list of type string. Alright, and if that thing comes back null, then we know that there's no information available. Otherwise, let's do the following. I know, and let's tell them how many things we know about this item. So data.size, right? LinkedList.size, that method tells us how many things are in the list. So I know data.size things about item. And then let's print them out one by one. So let's say fact number I, and then let's read the item from our linked list. Well, our linked list is called data, so we can say data.get parentheses I. That's the end of our facts, and that's the end of processing that item. And so all of this is the get command, right? And then the last piece of this is the error message. And then we're back to our main loop. So it's not a ridiculous amount of code. But you know, I would probably modularize it and break it into some pieces. But it basically goes from there to there. So you could make the get a function, the put a function, and then tighten this up a bit. But let's see what this does. Okay, I was going to be really surprised if it compiled on the first try. So go to your first error message, right? And I forgot to put starting quotation marks here in front of things. So put your quotation mark there, and then recompile, because that will probably clear some other error messages. Right, now we're down to 5 errors. Cannot find symbol linked list. Well, that's pretty easy, because you got to import it. All right. So save that, recompile. We lucked out. So let's go ahead and run this. So enter a command. Let's put some information. Specify an item you're saving information about. Okay, let's go for a dog. Enter 1 fact per line, end with a line with just a dot. So they like food. They like playing fetch. Sometimes they bark. And then I'll end with just a period. Okay, enter a command. Let's get information about a dog. And it says, I know 3 things about dog. And it tells me the 3 facts, 0, 1, 2. And I can put information about a cat. They are furry. They like to sit on whatever you're trying to read. And they have claws, and they're nice. Alright, so now I can say get information about a dog. I can say get information about a cat. And if I get information about something else, it says I don't know anything about that. Alright, so so you know, not you know, something that's going to replace Google, but a really good example of kind of a minimal use case for a hash map, where you're keying on one object and pulling values out and storing values that are a linked list, right? And so this is kind of the magic right here, right? The value associated with a key is a linked list, and once we pull something out by saying get an item from the database, right? That is a linked list. So data is a linked list, and it comes with things like a size method and a get method. Or when we're storing things, it comes with a put method or an add method. So we can store information in our list. And you can turn, you know, a lot of these sections of code into one-liners, right? I didn't need to make a linked list to add information to. I could have put an empty linked list into the database, and then down here I could have said the following. I could have said database dot get item dot put data. So I'm talking about some particular item here, right? And I know with that item I stored my linked list. So this will say fetch the data associated with item. That'll be a linked list. And with that linked list, I can go ahead and say add this piece of data to the end. And that'll work just as well. So put information about a dog, it's a D, an O, and a G. And put information about a cat, that's a C and an A and a T. And then if I get information about a dog, and if I get information about a cat, right? So it's still storing our information in there. It's just doing this in one line instead of storing the linked list up here. It's exactly the same thing, right? This is in all ways exactly the same thing as just fact list, because fact list came from fact list is a thing that was put in the database associated with item. All right. So that's just kind of a example I wanted to run through of putting some of these things together. So this is a parallel solution to what you're going to come up with for PA2. Same idea of a hash map, a linked list associated with a string. It's going to be a linked list of integers. And you're going to need to go through and add things to the end of it, but that's really not that much of a wrinkle, right? When I put information into the database, what I could have done, so where's my push section? So tell me some things about this. When I'm putting things into the database, instead of automatically making a new linked list, all I have to do is, before I do this, check to see if this item is already in my hash map. And if it is, just set fact list equal to database.get item. And now I can append things to my fact list for each item. If I try to put something in on an item that's already in there, it'll add it to the end of the linked list. And now you're really close to PA2. Alright, so I will post this up on the Linux server shared code area, but hopefully that gives you some ideas. Alright, so tomorrow is open lab, so keep working on PA2. Come to class, we can screen share, work on code, debug, whatever is helpful. If I don't see you tomorrow, have a great weekend, and I will see you next week. Alright, thanks everybody.